Students, so here it is your Araka sir. So I have come with another fresh and new episode on physics human eye for class 10 CBSE students. Okay, as per the request comes from the parents as well as from different students of mine. Okay, so that's why I am uploading this special topic for CBSE class 10 board examination. Okay. So, if you don't miss my previous episode where I have discussed about the different components, okay, the retina, clear, the sclera, optic nerve, clear, the blind spot, okay, the iris, okay. So, that all I have discussed. Okay, so if you missed, then you can go through the previous episode and you can see that. Okay, if you have any queries, you can write in comments. Okay. Now today moving forward, let us start the today's topic. So the first point is power of accommodation. Power of accommodation. Okay. So first topic is power of accommodation. Basically, what I told in the last episode that our eye lens is there. Okay, it's the convex lens. Clear. So now what happened when the ciliary muscles are there, okay, the round shape muscles, okay, ring shape muscles, ciliary muscles are there. So the ciliary muscles actually adjust the width, okay, or curvature of the lens of the eye lens, clear. So or the aperture of the eye lens actually, okay. So it will if it is thicker, then what will happen? Then it will have more converging nature, converging power will increase, okay. So we can see the nearby object. And if it is thinner, then the converging power will decrease and we will see the distant object. Okay. So now the thing is, what is power of accommodation? But we are when we are looking around, we can see all the things. Okay, where it is nearby or far. Clear. So that means what automatically, okay, the focal length of our eye is adjusted, okay, by the movement of the ciliary muscles automatically. If the object is very near to us, then what? Then we can see, okay, then we can see the focal length, then the what? The length will be thicker, and if the object is far, then the length will be what? Thinner, okay. Automatically this change will occur, okay, so that without any interruption we can see the nearby as well as the distant object, okay. So this ability, okay, is known as power of accommodation, okay. So in definition, what we can write? The ability to adjust the focal length of our eyes, to adjust the focal length of our eyes, so that we can see clearly and distinctly the near and far object is known as power of accommodation. Clear? Is known as power of accommodation. Clear? So what is power of accommodation? The ability of readjust the focal length, okay, based on the position of the object, whether it is situated near to our eye or far from our eye. Clear? The focal length of the eye lens will automatically be adjusted by the movement of the contraction or expansion of the ciliary muscles. Clear? So that we can see the nearby object or the far object very prominently and distinctly, means clearly, okay. So that is known as what? The power of accommodation. Clear? Now the range of vision, the range of vision. Clear? That means what should be the minimum distance of the object so that we can see that properly, or what should be the maximum distance of the object so that we can see that properly. Clear? Even if the power of accommodation is normal, still if there is a certain limit, clear, the lens cannot be thicker as much as possible. It cannot be. Clear? It cannot be done. It has a certain limit. That means it has also a converging maximum converging characteristics. Okay, or power it has. It cannot have more than that level. Clear? So it is said that if any object is set from the eye from a distance of 20 centimeter or above, okay, 20 centimeter or above. Clear? If for nearby object, okay, for the nearby object, if you can also experiment that at home. If you take the books, okay, if you keep the book very close to your eyes, then what will happen? We cannot read it properly. We cannot read properly. Clear? Even if you a single word also we cannot read if it is placed very close to our eyes. Why? Because the eye lens will be thicker and more thicker as the object will come near to our eyes. Clear? But that also have some level or some limit. The lens cannot go beyond that level. Clear? So up to 25 centimeter. Okay, if the object is placed from our eyes at a distance of minimum 25 centimeter, then we can see that object prominently. Okay, without getting any strain of our eyes. Clear? So this is what this is the short range, and long range for distance object it will be what? It will be infinity. Okay, infinity. Clear? So it will be infinity. Clear? So if no obstacles is there in between the object and the eye, and if the object is at infinity, then then also we can see that. That's why the stars blinking we can see, that is at infinity. The sun we can see, that is at infinity. That is at infinity. Clear? So the range of vision is from 25 centimeter is the minimum distance and maximum is infinity. Clear? So every object can be visible by our eyes if the minimum distance is 25 centimeter from our eyes up to the maximum distance is infinity. Clear? So that is the range of vision. Clear to all of you? Now let us move to the next topic. Okay students, now let us start to the next topic of today's episode. Clear? So that is persistence of hearing. Okay, so that is persistence of, what is the point? Persistence of vision. In case of persistence of hearing and vision, the thing is almost very similar. Clear? What is vision? So if any image is formed in our brain, image of any object, what we are watching is formed in our brain, then the effect of that particular image of that particular object will last for 1 by 16 seconds. It will last for how much? 1 by 16 seconds. Clear? If within that time period any other images are formed in our brain, then our brain cannot identify that separately. Clear? It will make a mess. So the effect will last of an image for an object in our brain, okay, which is carried by the optic nerve, okay, from our retina, okay, to the brain will be 1 by 16 seconds. So if within that seconds any other image will form, then we cannot identify that properly. Clear? So our brain cannot identify or distinguish that separately. So this is known as the persistence of vision. Clear? This is known as persistence of vision. Okay. So based on this application, actually the animation effect can be done. Clear? So the animation effect, okay, the cartoons and all what we are watching. Okay. So the image of that object for each and every steps are already drawn. Clear? And if it is coming within 1 by 16 seconds, okay, in front of your eyes, okay, first picture, second picture, third picture, fourth picture, like that, okay, very fast, then what will happen? The image will form, our brain cannot identify that, and the motion effect will start. Okay, we can see that the image is in motion, but that's the still image. Okay, so based on this application, actually the animation effect can be done. Okay, so what we can write? What is the persistence of vision? If any image is there, inside inside our brain, then the effect of that image of the said object will last for 1/16 second if any other image enters inside our brain within this time period, then our brain can't distinguish it separately. This is known as persistence of vision. Okay, so at the beginning I have used one term, persistence of hearing, almost same. Okay, so persistence of hearing means what? If any sound enters in our ear, then the effect of that sound will last for 1/10 second. Clear? If any other sound, okay, enters within that time period, then our brain also cannot identify the second sound or the other sounds. Clear? So that is known as the persistence of hearing. So that I will discuss in details, and how the echo form, why cannot hear the echo in a normal size room. So that all I will discuss in the sound chapter. Clear? So here the persistence of vision, that means if any image of any object is formed inside our brain, then the effect of that image will last for 1/16 seconds. Clear? If within that time period any other images are has entered in our brain, then our brain cannot identify that particular image separately. Okay, so this is known as persistence of vision. So it is what time period is 1/16 seconds. Clear? So hope the persistence of vision you have understood. Clear? So now let us start to some defect of eyes. Okay. Okay, students, now let us move to the next topic. That is the defect of eyes. Clear? So defect of eyes. So now first one, what we will learn? Myopia or short sightedness. Okay, short sightedness. Okay, by the name short sightedness means you have to understand that this is a defect of vision where we can see the object which is placed near to our eyes. Okay, means minimum distance should be 25 centimeter, that I told. Clear? But it is the nearby object we can see properly, but we cannot see the distance object properly. Clear? So this is known as the myopia or short sightedness. Okay, that means the vision is actually limited for the nearby object, that's why it is short sightedness. Okay, or it is known as myopia. Now what is the reason? So what is first short sightedness or myopia? Okay, the defect of eyes due to which we can see the nearby object. Okay, it should be greater than equal to 25 centimeter, but can't see the distance, can't see properly the distant object is known as myopia. Okay, it's known as myopia. Clear? It's known as myopia. So that means what? The vision is limited for the nearby object, but we cannot see properly the distant object. So this is known as myopia or short-sightedness. Very often this type of questions actually comes in exam. Now, what is the reason of that and what is the correction? Okay, how we can rectify this? Clear? So that we have to now understand. So first of all, reason. Students, what we know, that if the light is coming from the distant object, then what? The rays are considered to be parallel to each other. Clear? So when they will incident on our eyes, then what will happen? Then in case of the short-sightedness, basically our eyelids, okay, will become what? Thicker. That's why the converging power will increase. Our eyelids, okay, that is the defective eyelids will become thicker, okay, due to the natural contraction expansion will be destroyed of the ciliary muscles. So our eyelids will become thicker. That means what? The converging power will what? The converging power will increase. So what will happen when the ray of light parallel to the principal axis will act on it? Then converging power will increase. That means what? It will what? It will converge or it will meet, or the focal length will decrease. So suppose this is the retina. Okay. So the image will form in front of the retina. Clear? The image will form in front of retina. Clear? For the distance object. For the distance, the converging power will increase. Clear? And the length will be thicker of our eyes. So the image will form, that is the retina. It's supposed to be formed, the image supposed to be formed on the retina, but it is forming what? Before the retina. Clear? So that's why we cannot see properly the distant object. Clear? But the nearby object, it is thicker, so no problem is there. It has a high converging because the rays will be divergent. Clear? So it can converge on the screen. So no problem at all for the nearby object. But for the far object, the rays will meet, okay, or the image will form before the retina. Okay, or clear? So that's why we cannot see the far object properly. Clear? So this defect is known as myopia. So I am now writing this, okay, the reason. I am writing this, the reason. If the reason has come or will come in the examination, okay, then how I will write? Clear? The reason, and then I will draw the diagrams, and then I will also let you know how we can rectify it. Okay, how we can rectify it. Clear? So due to the increase of converging power of eye lens, okay, the lens will become more thicker and the focal length will decrease. So the parallel rays of light coming from distant object when refracted through lens, then they will meet or form the real image before retina, clear? That's why we can't see properly the distant object. Okay, so how will be the diagrams? Okay, so what? This will be the lens, clear? So the rays will be what? So suppose this is the principal axis, clear? So the rays will be parallel to each other, clear? So as it is thicker, so it will what? It will meet what? It should meet here, but it will meet, okay, before the retina, clear? So image will be formed before retina, clear? Focal length will decrease. This should be the focal length, but it decreased, clear? And another diagram, it is what? It is for myopic eye, clear? Another, if the light is coming from a nearby object, it is for far object. If it is coming, then what? The rays are divergent in nature, then what? It will come and meet on the retina, clear? So image will be formed on retina. So here no defect of vision will be there. We can see the nearby object. It is what? Nearby object, clear? And it is distant object, clear? So this is what? The myopic vision, okay? If a person is suffering from myopia or short sightedness, clear, then this actually situation occurs, okay? So when the rays are coming from the distant object, then they will be what? Parallel to each other, clear? And the due to the defect of the eye lens, it will be thicker, clear? The converging power will increase and the focal length will decrease. That's why what will happen? The image will form in front of the retina, clear? That's why you cannot see the far object or distant object properly. But in case of the nearby object, the rays which is coming from the object are divergent in nature, okay? So as the convergent power increases, so it will converge easily on the retina, clear? That's why if the object, the minimum distance we maintain minimum 25 centimeter, then we can see the object properly, the nearby object properly. But that's why our vision is limited to the nearby object, but cannot see properly the distant object. So this condition is known as the myopia, or this defect is known as myopia or short sightedness. So students, hope you have understood that. Now I will discuss how we can rectify this, clear? So students, now let us move to the next part, that is how we can rectify this problem, clear? That will be the last topic of today's episode. Last but not the least, very important for the exam also, very often it comes, okay? How we can rectify, okay? So see, so this is what? This is the normal defective eye lens, clear? So now see, so if we are using the concave lens as per the calculation or specification, if we can use the proper specified concave lens, we have to adjust the power, clear? Then what will happen? These rays will be what? Divergent in nature, clear? So what will happen? After diffracting, what? This will meet, okay? If we can use that properly, we can set the power properly, then after refraction to the island, the refracted ray will meet on the what? On the retina, and we can see the distant object. So this is what? Distance. Rays are coming from distant object. Clear? This is what? Concave lens. Clear? So this is the what? This is the focal length, okay, of the concave lens. Clear? And this is what? The light will meet on retina. Clear? Okay. So that is the rectification. Okay. Rectification of myopia. Clear? Rectification of myopia. Clear? So how we can rectify the myopia? In case of that, how we can rectify the myopia? In case of, we have to use the concave lens. Clear? We have to use the concave lens in okay, and we have to adjust the power of it. If we can use the perfect concave lens, then what will happen? The parallel ray of light will incident on the concave lens, and after refracting to the lens, it will be divergent in nature, and that will fall on the island, and after, because the islands will have a greater converging power, so after converging it will meet on the retina. Clear? So that's why we can see the distance object properly. So here, okay, the virtual image will be formed over here. Clear? So we can see that properly, and we can also find out the focal length, okay, by using the lens formula, 1 by v minus 1 by is equal to 1 by f. That formula we can use over here. V is the object distance, use the V use the object distance, V is the image distance, and this will be the focal length. Clear? So this is how we can rectify the myopia. Okay. So how we can rectify? We have to use the concave lens. Clear? In front of the eyes. Okay. The power should be adjusted properly, so that the parallel ray of light, when coming out from the concave lens, it will be divergent in nature, and when it will incident on the eye lens after refracted by the lens. Okay, eye lens means what? Nothing but the convex lens. Okay, it will meet on the retina, and we can see the object properly and clearly. Okay, so this is how we can rectify the myopia. Okay, so student, today's episode is up to this. Clear? So the next episode I will discuss about hypermyopia, okay, or long sightedness, okay, and some other defects of the eyes, okay, glaucoma, and also we will do some numeric problems on how we can adjust the power of the eyes. Okay, the patient having suffering from myopia or hypermyopia. So that we will do in the next topic, and that next episode, and that will be the last episode on human eye. If you can follow the three episodes I am uploading on human eye. So I think you will get all the probable questions from here, okay, and you can write the answer properly in the board exam. Okay, so without any miss, must watch, you have to watch the 3 episodes on human eye, special episode for CBSE class 10 standard students. Okay, so keep watching my channel and support me, and share the link to your friends or to your surroundings. Thank you for watching.